All right, today we're going to dive into a super important idea in machine learning called the Bandit Problem. Now, it's a core concept that helps AI figure out how to make decisions when things are uncertain. And as you're about to see, it's a dilemma that you and I face all the time, whether we're picking a restaurant or deciding what to watch next.
Okay, let's kick things off with a question pretty much everyone asks themselves. It's Friday night, you're hungry. Do you go to your go-to spot, the one that's always good, a safe bet? Or do you roll the dice on that new place that just opened up? It could be amazing, your new favorite, or, it could be a total bust.
Believe it or not, that very simple choice, sticking with what you know versus exploring something new, is one of the most fundamental challenges in all of artificial intelligence. This picture just nails it, right? It's the choice between exploitation, that's pulling the lever on the machine that's been working for you, and exploration, trying a whole new machine, hoping you might find an even bigger jackpot. So in the AI world, this classic dilemma has a name. It's called the Bandit Problem. And really, getting a handle on this is the key to understanding how machines learn to make smart decisions when they don't have all the answers.
So what is it exactly? Well, the name itself comes from those old-school slot machines, which people used to call one-armed bandits. The official term is the K-armed bandit problem, where K is just a placeholder for the number of choices you have. So picture a row of slot machines, each with an arm. Your job is to figure out which one of those arms is going to pay out the most over the long haul.
Okay, so let's break this down. What are the pieces of this puzzle?
First, you've got your setup, a machine with K arms. Each of those arms represents a different action you can take. Every time you pull an arm, you get some kind of reward, a number. And the big objective, the whole point of the game, is to get the highest total reward you possibly can over many, many pulls, which means you have to learn which arms are the best while you're playing. And this is where we get to the heart of the matter, the central conflict of the bandit problem. It's a trade-off that every single decision maker has to deal with, whether you're a human or a machine, the constant battle between exploration and exploitation. So on one hand, you've got exploration. Think of it as being a detective. You're trying different things just to see what happens, to gather more information. It's about trying that new restaurant. You might take a small hit in the short term, but you're learning something valuable for the future. And on the other hand, there's exploitation. This is all about using the information you already have. It's going to your favorite spot because you know it's good. You're cashing in on your best bet. The entire challenge is just figuring out how to balance these two.
You know what? To really make this click, let's walk through a simple example together. We'll ditch the casino for a minute and head back to our restaurant problem. But this time, let's see how a computer program might try to solve it. All right, here's the setup. We have 3 restaurants we can pick from. Now, we don't know this, but Restaurant 1 is secretly the best with an average happiness score of 10. Restaurant 2 is pretty good, an 8, and Restaurant 3 is just okay, a 5. Our mission is to pick one place to eat every single day for 300 days, and our goal is to get the highest total happiness score possible.
So how should we tackle this? Well, let's try strategy 1, the exploit-only approach. This is a pretty simple, maybe even a little naive strategy. We'll try each restaurant just once, and then we'll just stick with whichever one seemed best from that first impression.
Okay, so here's how it plays out. Day 1, we go to Restaurant 1, but we just get unlucky. Maybe the chef had a bad day, and we only get a happiness score of 5. Day 2, we try Restaurant 2 and get an 8. Nice. Day 3, we hit up Restaurant 3 and get another 5. So based on this tiny little bit of data, our algorithm decides, hey, Restaurant 2 is the clear winner. And so it locks in that decision and just goes to Restaurant 2 for the next 297 days straight. So fast forward 300 days. What's the final tally? Following this exploit-only strategy, we end up with a total happiness score of 2,300. And, that sounds pretty decent, right? But here's the real question. How much better could we have done? What if we'd somehow known the perfect choice from the very beginning? And to figure that out, we need to talk about a really important idea in machine learning called regret. Now, this isn't an emotion. It's a number, a metric that we use to see how well an algorithm did. It literally just measures the size of your missed opportunity, the gap between the score you actually got and the perfect score you could have gotten if you'd made the best choice every single time. And for our exploit-only strategy, the regret is a whopping 700. Now, where does that number come from? Well, the perfect score, if we'd gone to the best restaurant every day, would have been 3,000. That's 10 points times 300 days.
We only got 2,300. That 700-point difference, that's our regret. That's all the happiness we missed out on because our strategy was too quick to judge and didn't explore enough to find the real best option. Okay, so obviously, jumping the gun and just exploiting is not the way to go. It can be super costly. We need a smarter strategy, something that balances things out. And that brings us to one of the most famous and honestly elegant solutions out there, the epsilon greedy algorithm. The idea here is just beautifully simple. Most of the time, let's say 90% of the time, you act greedily. You exploit what you know and pick the option that has the best track record so far. But for a tiny fraction of the time, we call this fraction epsilon, say the other 10% of the time, you explore. You completely ignore what you know and just pick an option at random. That tiny chance to explore makes sure that the algorithm can never get stuck on a bad choice forever. Now, this whole thing isn't just some fun thought experiment with restaurants and slot machines. This explore-exploit idea is everywhere. It's the engine behind so much of the technology that we use every single day. Let's take a look at how this plays out in the real world with different kinds of bandit problems. Let's start with the simplest version, and really, this is the engine that powers something you've probably heard of, A/B testing. Even though you usually have two choices, like version A and version B, the problem is about figuring out the value of that one decision. Seriously, this is everywhere. When a company tests two different ads to see which one gets more clicks, that's a bandit problem. Or when an e-commerce site tries two different website layouts to see which one makes people buy more. Or an email with two subject lines, or an app with two different icons, all of these are about quickly finding the winner and exploiting it to get the best results. Okay, so moving on, we have the K-Armed Bandit. This is the classic setup we talked about with our 3 restaurants where you have K different options to choose from. This is for more complex situations where you have a bunch of different paths you could take. And here, the stakes can get really, really high. Think about medicine. A K-armed bandit approach can help doctors figure out which of several treatments is the most effective for a patient. Or in networking, it's used to find the fastest way to send information across the internet. In video games, it's how an AI player learns which move is the most likely to help it win. All right, but we can take this even one level deeper to what's called a multi-armed bandit problem. Now think about this. It's not just about picking one thing out of a lineup. First, you have to pick the right lineup, and then you have to pick the best option from within that lineup. And if that sounds familiar, it should. This is exactly how modern recommendation engines work. A platform like Netflix or YouTube first has to decide which category to recommend to you. Should it be a comedy, a thriller, a documentary? That's choosing the machine. Then it has to pick a specific movie from that category to show you. That's pulling the arm. This same idea powers everything from dynamic pricing online to where ads get placed on a web page. So, to wrap this all up, let's put you in the driver's seat. Imagine you're running a huge streaming service. You've got a user who watches action movies all the time. Do you keep exploiting that knowledge and just feed them more action movies you know they'll probably like? Or do you take a chance and explore? Maybe you recommend a critically acclaimed documentary, something totally different that they might end up loving even more. That choice, right there, is the bandit problem in a nutshell. And finding the perfect balance is the secret to building smarter, better, and more personal experiences for all of us.